Hey everyone, welcome back to the channel. If you're a Tesla owner, you know that while these cars are amazing pieces of technology, they can sometimes throw a curveball with a tricky fault code. So, what does that mean for you? Well, the onboard charger is the component responsible for converting AC power from your wall outlet into DC power that can be stored in your high voltage battery. When it can't communicate with the rest of the car, charging can become slow, intermittent, or might not work at all. It's a critical component for the daily usability of your Tesla, so getting this sorted out is a top priority. First things first, where's this elusive onboard charger located? On most Tesla models, you'll find it tucked away behind the front bumper, usually on the passenger side. It's a fairly hefty silver or black box with several high voltage and low voltage connectors. Getting to it might require removing the front undertray or even parts of the bumper cover, depending on your specific model and year. Always remember to follow proper safety procedures, especially when working near high voltage components. Now, let's talk diagnosis. The P0D26 code is all about communication, so our primary suspects are the pathways that allow the OBC and the PCM to talk to each other. This communication happens over what's called the CAN bus network. Think of it as the car's internal internet. A break or a disruption in this network is what triggers the fault. Our diagnostic journey begins with a visual inspection. Start by examining the wiring harness that connects to the onboard charger. You're looking for any signs of physical damage. Has the wiring been pinched, chafed, or chewed on by a rodent? It happens more often than you'd think. Pay close attention to the area where the harness routes through the body, as these can be common chafe points. Next, focus on the main connector for the onboard charger itself. This is a large, multi-pin connector. We need to check for a few things here. First, is it securely seated? Over time, vibrations can sometimes cause connectors to work themselves loose. A simple push might be all it takes to solve the problem. Second, we need to inspect the pins and terminals inside the connector. Look for any signs of corrosion, which often appears as a green or white powdery substance. Corrosion can create resistance and block the delicate communication signals. Also, check for any backed-out or bent pins. A single pin not making contact is enough to bring the whole system down. A good contact cleaner can work wonders on a corroded connector. But B. Hentley. If the visual inspection of the wiring and connector doesn't reveal any obvious issues, the next step is to get a little more technical. We need to test the integrity of the CAN bus wires themselves. You'll need a multimeter for this. You'll be checking for continuity on the CAN high and CAN low wires between the OBC connector and the PCM connector. This will tell you if there's a break in the wire somewhere along its path. You'll also want to check for any shorts to ground or shorts of power, which can also disrupt communication. This requires a wiring diagram for your specific vehicle to identify the correct pins. So, what if the wiring checks out perfectly? The CAN network is solid, the connector is clean and secure, but the fault code persists. At this point, the evidence starts pointing towards the onboard charger module itself. Internal failures within the OBC's control board can prevent it from communicating, even if all the external wiring is perfect. This leads us to the fix. If you found a loose connector, the solution is simple. Reseat it firmly until it clicks. If you found corrosion, clean it thoroughly. If you found a broken wire, you'll need to perform a proper repair, which usually involves soldering and heat shrinking to ensure a durable, weatherproof connection. However, if your diagnosis points to an internal failure of the onboard charger, then replacement is typically the only option. Replacing the OBC is a significant job. It involves safely disconnecting the high-voltage system, unbolting the old unit, and installing the new one. After installation, the new module often needs to be programmed or configured to the vehicle using specialized diagnostic software. This is a procedure that might be best left to a qualified technician if you're not comfortable with high-voltage systems and vehicle programming. To recap, P0D26 is a communication fault between the onboard charger and the powertrain control module. Start your diagnosis by inspecting the wiring and the main connector at the OBC. Check for damage, corrosion, and a secure connection. If the wiring is good, the problem likely lies within the onboard charger module itself. The fix can be as simple as reseating a connector or as complex as replacing the entire OBC module. I hope this breakdown helps you tackle the P0D26 code with confidence. Working on these advanced EVs can be incredibly rewarding. If you found this video helpful, give it a thumbs up. And don't forget to subscribe for more deep dives into Tesla diagnostics and repair. Drop any questions you have in the comments below, and I'll do my best to answer them.